Illustrations and data visualizations often cannot convey the whole information by themselves and instead rely on labels in the form of short textual annotations. How labels are positioned greatly impacts the quality of the visualization. Some important things to consider include label readability, ambiguity, compactness, and aesthetics. And while manually labeling an illustration can be easy, it can also be extremely laborious. It is not surprising, then, that many algorithms have been developed to automate the labeling process, which have achieved, well, moderate degrees of success. Most of these algorithms are very limitative because they exclusively use either internal labels or external labels. Some use both types, the mixed labeling algorithms, but the labels often overlap. In this paper, the authors propose the mixed labeling algorithm that takes into consideration the four major concerns we saw before and avoids the overlap between labels. It works in both 2D and 3D objects, it is able to handle overlapping areas, and operates in real time. The first step is to provide the algorithm with the labels and an image which is encoded and where each element is uniquely identified. Then, heuristics and a greedy algorithm are used to solve the optimization task and determine the best label layout. Take this example. This illustration has three distinct 2D marks or areas. The algorithm first selects one area, starting with the one that has the lowest number of possible label placements. It will then find the internal label candidate with the maximum fitness, including partial overlaps. However, if the selected label is ambiguous, then the algorithm will search for an external label instead. It will continue to iterate until all unique areas are labeled. So, what determines the fitness of a label? The authors use multiple criteria, but they all share a common goal to minimize ambiguity. This is why the current label for object A was considered better than, for example, this one. Now, the logical question is, what is considered to be ambiguous? Conveniently, this can be defined by the user with the ambiguity threshold. An internal label is considered ambiguous if its fitness is below the threshold, causing it to be replaced with an external label. This threshold can be tweaked to force the algorithm to exclusively use either internal or external labels. The main innovation and certainly main challenge of this method was ensuring that there are no overlaps between labels and leader lines. To prevent this, when a label is placed, the algorithm creates a restriction zone around it where no other labels or leader lines can be positioned. So, how well did the algorithm perform after all? To answer this question, the generated label layouts were compared to those produced by an experienced illustrator. The results were very similar, but there were some important differences. In the map of the Caribbean, the illustrator placed the labels so that they wouldn't cover the smaller islands like the algorithm did. In the case of the human head, the illustrator always placed the labels inside the illustration to maximize compactness, even if they had leader lines. Despite a large room for improvement, the algorithm was shown to be a useful tool, applicable to different types of illustrations and producing label layouts similar to the manual approach in a much faster way. By allowing the user to give preference to internal or external labels, it presents great flexibility, and even the simplest graphical elements were carefully considered, such as the use of straight line leaders, which were shown to be one of the most readable leader types.
Created using Powtoon.